Which tools are available to embedded engineers today to make cloud connectivity simpler? Join me, Todd Baker, in this episode of The Current as I walk you through the system designs that Future Connectivity Solutions Group has created to make embedded cloud design more efficient and faster to increase your time to market. So, I remember when I was an early young engineer, probably around 2003, 2004. One of my first designs was I was working for a design firm here in Austin, Texas, and we'll say a major shipping company had come to us and asked us to build a tracking system for all their trucks that are going all over the place all the time, and they wanted to monitor temperature of the tires, tire pressure, rotation, movements, and all that, and they wanted that data live, on a server somewhere. And back then it was cellular. I had a little flip phone. I mean, that was all we had as far as cellular goes.
Yeah.
And so, how do we do this? And we had found, I think, a Sprint cellular module that we were utilizing and trying to get that connected up. We had to do our own server for the thing, get all the data up, and it was a ton of work. And fortunately, I was working with some brilliant engineers who figured out how to get it all done. But the world has changed a ton. And when you've got an embedded system like that, getting data up onto a server is light years simpler than it was back then in the Stone Ages when I was doing that design. And that's what we want to talk about today, is just how easy it is to get today's embedded systems up and connected to the cloud. And so I'm Todd Baker, Corporate Vice President of Engineering at Future Electronics. I'm speaking with Mark Calhoun, who's one of our wireless specialists with Future Connectivity Solutions Group, FCS. And so, Mark, thank you very much for joining me and speaking to me today about some of the systems that you and the team have designed to make cloud connectivity of embedded systems a little bit easier. So tell me a bit about you. What's your background? What's your experience in wireless prior to coming to Future?
Yeah, sure. I've been in this industry for about 10 years and, mainly focused on Wi-Fi and Bluetooth and networking. So I started in networking in general, got into RF, did the Wi-Fi Bluetooth thing, and that naturally led to IoT and LoRa and now cellular and so on. So that's kind of a big role for me here at Futures to help with the cellular components of designs.
Right, great. Yeah, and certainly a tremendous amount of experience, I think, that's bringing us a lot of value. What are some of the applications you're seeing right now? I mean, we've been talking about this whole Internet of Things and IoT for years now. It seems like for 5 years, and it continues to be a big area. Everybody's trying to connect everything, including the refrigerator, the toaster, the car. All of it has got to be connected to the internet these days. What are you seeing as some of the cool areas of growth and applications that you've really enjoyed and thought were kind of unique?
Yeah, absolutely. You're spot on with the toaster comment. I mean, it's all about getting everything connected and getting data to the cloud, right? And so some of the cool applications are definitely in the medical field, tracking an asset around, whether it's a person, a device, getting sensor data. Telehealth is huge right now. Definitely smart farming. So think about all of that antiquated equipment's out there in the field. It's acres and acres of land, and you want to know about the crops, whether it's the dirt in the ground, you have a sensor there, or it's the machinery and how it's running, and that's got to get all the way back somehow, and the answers through IoT connectivity up to the cloud. And how do you do that? So
yeah, and it's a huge challenge. I mean, if you're just a hardware engineer like myself, very good with copper. As soon as you have to figure out how to transmit data over the air, it becomes a little bit of black magic, I think, for a lot of us, although it's becoming more and more common. And I think the great thing about that is the skill set of the engineers in the industry is continuing to get better and better in this space. And we're going to see a lot of innovation there and a lot more expertise in that area, which is just phenomenal. And I think really exciting for our discipline as engineers. But with that, as a lot of these hardware guys like myself, right? Copper guys, I know microcontrollers very well. I know my SPIs, my UARTs, my I2Cs. What are some of the struggles you've seen over the years and the hardest things to overcome when it comes to any kind of a wireless design?
Yeah, yeah, good point. And it can be kind of daunting sometimes because you're trying to take your traditional PCB and how do I get it to RF, right? And there's so many avenues, and that's probably one of the biggest challenges is what do I use? Do I use classic Bluetooth, Bluetooth Low Energy, Wi-Fi, cellular, LoRa, Sigfox? There's 20 different types of cellular technology. So figuring out what's the right technology for your application is the big one, and then how to integrate it and how to get it to market in terms of certification and stuff like that.
Yeah, yeah, I think that's always the big challenge. I think the other challenge that we run into a lot is how do I do this cost effectively,
Hmm.
so that I actually can hit the market that I'm trying to hit and have
Yep.
a product that end customer is going to actually be willing to pay for,
Yeah.
is always a challenge in that. So how are some of the ways that you think you can help with that? From a cost standpoint, are we able to have we seen those costs coming down? And
Yeah.
are we able to get into more applications now than we have in the past?
Yeah, yeah, absolutely. And so, cost is always a factor, time to market's a factor, and the cost has definitely come down on hardware. And when we're talking connectivity, specifically cellular, definitely come down on data too. So it used to be very expensive. You talked about your application, with the shipping company,
Yeah. Jeez, it was
and
nuts. Yeah.
yeah, data is expensive. Modems are expensive. But now, with a Cat M1 module or something similar, it can be $1 a device per month. And so it's massively more affordable. And when you think about, maybe an application like a laundromat where you have 20 washers and dryers and you want sensor data from that up to the cloud, that's a lot of devices. And so to have that only be $20 a month for the whole laundromat is critical.
Yeah. Yeah, that makes a ton of sense, and that's exactly what we used to run into, right? I mean,
Yeah.
when it came time for us to hook my Sprint module up to the Sprint cellular towers, there was no
Hmm.
option on plans, right? The only plan that we could go and get was the typical cell phone plan, which
Yeah.
was at that time $80 a month, $90 a month, whatever it was, which was just crazy. How are you going to do that if you have a ton of nodes out in the field and every one of
Hmm.
them's got to talk? And so now we see obviously a lot of changes and really cool expansion in the cellular radio industry with all these new standards coming out like CAT-M.
Hmm.
So how does an engineer decide which cellular standard and which cellular solution is right for them?
Yeah. So, for me, there's kind of two things here. One's you can rule of thumb it a little bit. So, if it's an application that doesn't require video or high throughput, you can start looking to the left, so to speak, at like LTE Cat M that you mentioned, NB-IoT, lower throughput things that are more cost effective as well and cost less per month and just suit your application fine. And then if
Right.
you need higher throughput like video or something, you can look more towards LTE Cat 4 and beyond. So that's kind of the rule of thumb, one. And two is to lean on a team like what we have at Future with Future Connectivity Solutions, contact, someone like myself or one of my colleagues that can help you select the right technology for your application.
Yeah, I fully agreed on that, and I'm obviously biased, but
Yeah.
I'm a big fan. It's really cool when you get to work with engineers that really know this stuff
Yep.
backwards, forwards, and upside down. Have such a broad range of experiences that you guys in FCS do.
Hmm.
So for me, as an old microcontroller guy, that's it's a breath of fresh air to be able to work with guys that know things that I don't and can help me with all that kind of design. So you know when you're doing a cellular design specifically, one of the other
Hmm.
things that we've seen with a lot of customers is whether or not they want to go with either a cellular modem, or if they want to go with an end device certified modem, excuse me, a
Yeah.
cellular module or an end device certified
Yeah.
modem. What's the difference between those two, and how does a customer really make the decision on whether to go with the modem route or the module route?
Yeah, yeah, absolutely. And so, a lot of engineers might be familiar with like a chip down approach a lot of times if they're trying to
Right.
do RF. It kind of relates here with the module and modem. So, a module is kind of what you would expect a standard either Wi-Fi, Bluetooth, cellular, whatever it may be. It's got the RF components in there, some type of power, potentially a little microprocessor in there with it to drive things, and typically has some modular certifications, right? So you're good for FCC and so on. But when you're talking cellular, then you got to think about PTCRB, the regulatory body for that globally, and then also end device certified, and that's where the modem comes into play. And so with end device certified modems, they go to a network provider like AT&T or Verizon and actually do testing and get certified to be on the network. And that can be a gotcha for a lot of people because you'll be going through with a module and think, hey, I'm good. I got a modular certification. Let's go launch this product. Oh, now I'm
Right.
pushed out 6 months maybe, and I have to pay
Yeah.
a lot of extra money and do testing. And so that's the difference in the consideration between, time to market and cost.
Yeah. And that time to market is so critical. I mean, I've
Yeah.
seen so many customers, and I'm sure you can probably list examples as well, who had a great idea, started their design, were going down the road, and then ran into something like that, or ran into something like FCC certification testing that they were just struggling to get through,
Yep.
and then they missed their market window, or their competition got 6 months of ahead of them, and that kind of thing's always definitely a challenge to see. In something that I think we can bring a lot of value in helping those customers with. So, again, going back to me is a hardware engineer who understands my microcontroller very well. I understand my sensors. I know how to understand how to do serial communications and things along those lines. If I were starting a new design today, talk to me a little bit about the platform that you and the FCS team have developed. And then kind of how you would use that, as a new design engineer or a design engineer who has a new design, how you would use that to get your design up and going.
Yeah, sure. So, in terms of something that we worked on, I'm sure you're talking about the microchip and U-block solution. Yeah.
Correct. Yes,
Okay,
yes,
cool.
yes. Thank you.
Yeah, that's definitely a very popular one for us and a new one. And I actually have that here on my desk with me. And so, I'll hold it up to the camera here a little bit, and there'll be videos linked, I'm sure, here. But this is I'll take it apart, just a microchip board. And this happens to be AVR BLE. There's a PIC version too, so Bluetooth, low energy. There's also a Wi-Fi version. And then a U-block Sarah R4. And so talking about, a new design, like you asked, to be able to take something from microchip that has a couple of sensors on it, accelerometer, temperature, and so on, along with Bluetooth, and pair it up with something like cellular, that's pretty powerful. And the trick is to be able to do that easily and quickly there. But to start a new design, I would, recommend getting something like this. And it's a click header here, and you can just put it together like that, and you're up and going. You hook up an antenna. In this case, it's a tile glass antenna. Pop in a SIM card. We have a Convergio SIM card in there, and then you can get an out-of-the-box demo and start running with it. And then in terms of this project, we have stuff to expand on that as well.
Right. And so probably a lot of the people, the engineers listening, are familiar with Arduino and things along those lines. Microbus, I think, is a slightly newer standard, maybe not as quite as well known. So, I think that it's kind of the similar type of a thing with the microbus. So then once that's plugged in and you've got the U-block cellular modem plugged in to the microchip microcontroller, all the drivers are there ready to go. It's really just all kind of half done for you at that point. Is that correct?
Yeah, exactly. So we did a couple things with this. Very plug and play, like you mentioned. The drivers are there once you plug it in. In terms of actually running an out-of-box demo with this, it's a simple hex file that you drag and drop onto the board. If you're on a Windows machine, it's like Windows Explorer, drag and drop the file within seconds, you're done. And then if you want to expand beyond that, you can get the source code on GitHub from our team.
Okay. Yeah. And so, I think that's your claim to fame with this design, right? Is really just the idea of out of the box, and you've got something that's very configurable, up connected to the cloud within 20 to 30 minutes. Is really kind of the idea and the goal behind that. So we'll include some videos on that, in the links below the video that we have here, so that our audience can take a look and see that demonstration and see how that kind of connects to everything. How configurable is that? So obviously it's my problem with a lot of demo boards and eval boards out there has always been, you get the board and it's whatever it is. So whatever that particular design engineer designed it to be, it does your blinking LED or whatever it might be. I'm trying to monitor a vehicle on the road or whatever might be my application. How do I go from what you've got in your board to what I really need to design for my manager?
Yeah, great question. And it's all about use case and getting up and running into the market, right? So you have the great out-of-box demo that Microchip already kind of had with this board, and we just paired the cellular to it and built upon that. And so if you go into the GitHub page, all the documentation instructions are there. There's videos, there's screenshots. list of 10 AT commands to get your cellular module connected. And that's a big part of it, that next step, because there's so many guides and AT commands and pages and pages and pages, but we want to serve to you on a silver platter. What do I need to get going? And then the step beyond that is the source code. And so you get the source code from GitHub, from the FCS page, and then there's a small API in there that we wrote that you can feed commands into to take things to the cloud over this cellular connection. And being that there's sensors on board and everything already, you can just pluck from those functions right into the API and you're up and going. Not to mention there's a lot of useful tools and documentation from Microchip and uBlocks, as well as code examples. So you can just kind of drag and drop and plug things in or pull in some functions and you're off running left or right from where you've started.
Man, things are so much nicer now than they were when I was in here. I mean, you're starting, and I'm still an engineer, but since I was doing design, and that's great. I mean, because there you've got really a launch pad for your design. You can take the work that you and the team have already done, Microchip's done, uBlocks has done, Future's done, take that code and really configure that code, add your own application code on top of it, and be ready to go and really, innovate the exact design that you're trying to get to. And I love that for design engineers out there because it gets them to market faster. It's going to allow them to be successful faster. Half the job is already done, which I'll tell you in 2003 was not the case. I can tell you that for sure. So, what are some of the main benefits? I mean, obviously you guys chose uBlocks and Microchip for this, but there's a ton of wonderful semiconductor suppliers out there, and a lot of really great companies. So why did you guys choose uBlocks for this particular design and Microchip? What's the power in the partnership between those two that maybe is a little bit differentiated from some of the other solutions out there?
Mm-hmm. Yeah, great question. So, one is just the ability to have these kind of out-of-box demos that you can build upon very quickly was one key component, but really the tools and documentation. So in the terms of Microchip, MPLab, X, IDE, using the AVR, pick with that. I cannot sing enough praise about it. And it's not just because I helped work on this project with the team. It was so much easier with the features they have in there specifically for the PIC or for the AVR. There's a few things that were drag and drop shortcuts that saved me a lot of time. There was a couple of code libraries that saved us a lot of time. So it's a very useful tool, whether you're a beginner or expert, in my opinion. On the uBlocks side of things, they have some of their, what I would call center tools. They have like it's called M Center is their cellular version. And if you think about like a PuTTY or a TerraTerm or something like that, very similar, but with a lot of extra features packed around it, centered around this cellular module. And so you have a list of commands in there. So you can say, hey, I want to do this type of test. And the commands are already there for you. And you can run through them and see what they do. You can even load in your own commands. So just powerful software that helps your design is why we chose Microchip and uBlocks.
Yeah, and I think that's really where all of the different silicon vendors right now are differentiating. I mean, I think everybody's kind of standardized when it comes to like microcontrollers and things along those lines. Yeah. ARM has become the de facto standard in a lot of ways in these embedded systems, that are, at the edge of the cloud. And so, it gets to a point where a lot of these microcontrollers end up looking the same. There's some slight differences in peripheral sets. There's some slight differences in the way that they can do low power down modes and things like that. But the real differentiation today, and I think it'll change again, but today seems to be in the IDEs. It seems to be those kinds of tools that you mentioned are really what makes a lot of the power in why you would select one microcontroller over another. And that's really a cool thing. I think there's a lot of great options out there, but it's cool to see what the MPLab system is doing right now and how that's making it easier for these kinds of designs. That's a really powerful thing. So the other side I think most hardware engineers have and the challenges is if your bosses come in, ask you to do this design, make it wireless, make it connect to the cloud. The next thing they're going to ask you to do is I want an app on my phone. I want to collect all the data on my phone and be able to have an app where I can control things and all that. And that's usually kind of a little bit of a foreign land for a hardware engineer as well. What recommendations and thoughts do you have for engineers that have that problem?
Yeah, for me, it's always been rely on the experts when you can. So you can't know everything; it's impossible. And if you are, you're probably not in the position you are. You're going to be moving up very quickly away from this type of work. So for me, on hardware, I rely on experts. So it's kind of the opposite case because I'm more software oriented, more networking
Yeah,
oriented than RF,
yeah.
and so I go to the experts, and that's kind of what we do. We have a lot of great partners at Future that can help with that type of thing. And we also have the FCS team here in Future Connectivity Solutions. So we have a resource on our team that does a lot of software and app development and can help with those types of things. So I would say reach out, talk to us about your application, or talk to a partner about the application, and we can put you in the right direction, or even do some type of design or coding work for you.
Yeah, I think between our internal resources and then also external networks and third parties that we can hook different design engineers up to,
Yeah,
that's been a really powerful thing.
yeah,
The know-how that you guys and the FCS team have built there is absolutely incredible, and
yeah.
something that I think everybody should take the time to at least take a look at, and
Yep.
see what we can do for you there. Um, so then I think the last thing that was always a big challenge, for me, again, going back to my design. We were trying to, I had a 2.4 gigahertz. It was an old ChipCon radio. We were doing
Yeah.
802.15.4. We weren't doing Zigbee. We were doing our own proprietary wireless stack. But we were trying to get a 2.4 gigahertz 802.15.4 radio out of a 18-wheeler truck tire, which is a perfect Faraday cage.
Yeah.
And get that from the truck tire at the back of a semi all the way to the cab, which was it was fun. It was some days it was fun, some days it was less fun. But that's a huge challenge. And that we were going chip down with our little chip con,
Mhm.
and for that we had to go through FCC, and we were very fortunate. I had some amazing RF engineers, much better in this area than I am, that I was working with. I think we only had to go to the lab twice to get FCC certification, which
Yeah.
was a little bit unheard of.
Yeah,
Usually
you're
it's
lucky.
3 or 4 times, I think, in most
Yep.
chip down designs. So for a customer that's having to do that, go through chip down certification, or in the case where maybe they need an antenna design with a module, what do you
Mhm.
recommend for those engineers? Because man, when you've got to get into that Bodhi plot and all that kind of stuff, it's
Yeah.
painful.
Yeah.
So what's your recommendation on that side of things?
Yeah, so this is probably another two-pronged answer for me. One is to just be cognizant of the certifications. Is it a modular certification? Is it certified in FCC for US, ETSI for Europe, and so on? And what type of antenna are you using? And if you have enough expertise in that area, make sure that the rule of thumb is it's got to be equal gain or less. So you can't come in with a different antenna that fits your design or application and have higher
Right.
gain. You're going to violate certification. You're going to have to test and go back, and that's wasted time and money. And time to market takes longer. So beyond that, find an expert. And again, the FCS team here, we have an antenna specialist. His name's JD Wu, amazing guy, engineer. Yeah,
Yeah.
you know him a little
Yeah.
bit.
Yeah. Yeah.
So
Yeah.
you'll tell him, hey, there's my application. Here's the module I want to use. Here's the certification. He'll say, look, here's 5 antennas you can use that are not going to violate anything. And boom, you're on your way running, no problem.
Yeah. Yeah. Yeah, and not to tell stories on JD, but I think we've had a number of occasions where we've had applications with customers helping their design engineers, and we've had radios that radio can't get more than 300 meters. JD takes a look at it and says, "I can get 600 meters out of that," and the supplier said, "JD, you can't. It's not possible." And then JD a week later comes back, "Hey, it's doing 600 meters now," and they're just jaws are on the floor. So
Yeah.
it's great to have a resource like that, and be able to offer that resource to other design engineers is really cool. So great. So Mark, this is phenomenal. I could not be more excited about the cloud connectivity kit that you and the team have developed with U-Blocks and Microchip. I think the ease of design that really offers in any embedded system is a real
Mhm.
game changer. It's something I really appreciate you sharing with me today. Again, we'll link some of the videos, to this that you've already built below,
Mhm.
so that anybody that wants to take a look at it can get some information. If you're interested in the kit, please let us know. Please, go ahead and send us an email at shapingthefuture at futureelectronics.com. And let us know if you have any needs on that. We're happy to help out any design engineers out there that are looking at
Yes.
these designs, and make sure that you guys are successful with Mark, with the rest of the FCS team, and with our overall advanced engineering organization. So, Mark, again, thank you so much for the time, sir. Absolutely
Yeah.
wonderful stuff. And we'll look forward to talking to you soon.
Awesome. Thank you for the time, and I appreciate the questions.
All right, take care, all.